This video also continues dispersion for scale variables. Specifically, this video talks about dispersion around the mean, and you should focus on variance and standard deviation. I will go over other methods of finding dispersion around the mean, but you should focus on these two, and the one you should focus on the most is the standard deviation.
Okay, so say we have the sample data, this population data. We have values 3, 4, 5, 5, 6, and 7. We want to find how far away a typical value is from its mean. So say we take the mean of these values, and we'll get 5 if you do that. And then we want to see how far away a typical value is from its mean. So one way to do that, maybe you might think, well, let's just subtract off the mean. Okay, so 3 minus 5 is negative 2, right? And so 3 is 2 spaces below 5, its mean. We do that for 4, you'll get negative 1. You do that for 5, you get 0. You do that for 5 again, you get 0 again. And we do 6 minus 5, we get 1. And we do 7 minus 5. You'll get 2. Alright, so then you're like, okay, we have all these deviations from the mean, so this is how far each value is from its mean, but how can we get a typical value? Well, we could either total them up, and then, or we can take the mean of it. But either way, if we total these up, see what happens? We actually get 0. Isn't that weird? So when you do it this way, what will happen is it's going to look like that there's no spread. There's no real deviation from the mean, because if you take 0 and then divide by 6 to get its average deviation, you're going to get 0 still. That makes no sense, right? These don't typically vary from the mean by 0. I mean, there is some zeros, but not all of them are zeros, so this should be 0. So doing this doesn't work, because the negative 2 cancels out the 2, the negative 1 cancels out the 1, and so we're end up with 0. So this isn't going to work, so we're going to have to find a different way to fix it.
So we need to get rid of the signs when we're adding up the deviations from the mean. We don't want them to add to 0. So there's two options. We can take the absolute values of the deviations, or we can square the deviations. Both of these ways will get rid of the negative signs. When we average the squares, it's called variance. Variance has what I call magical in math properties. And it's easier to do math with squares than it is to do with absolute values. And it use those in algebra and also in calculus. And even though you don't need to know calculus for this class, it's kind of used behind the scenes in statistics, and then it's specifically used in statistical theory, which you don't need to know, but you just need to know it has these magical properties, I mean. So we will always use variance instead of the mean absolute deviation. So we're going to use the square version instead of the absolute value version. And the squared version is called variance. So variance wins. And you can see the footnote on standard deviation at mathisfun.com, and this will kind of explain a little bit more why we use variance over the absolute value version.